Welcome back to the Admiral 19A15 restoration. I'm digging deep into the chassis now. I used my experience from the other sets I worked on recently and knew that taking the tuner out makes working on this a whole lot easier. It's not too bad. Take a few sheet metal screws out of the top, disconnect a few wires and a grounding braid and the antenna leads, and good to go. It not only frees up this area, it shaves some weight off the chassis, as does removing the CRT, and then you can really get in there. So, speaking of getting in there, before I just go and shotgun all this stuff, I wanted to fire up the Pyramid CRA1 and demonstrate it again about how it works and what it can do. So, one thing I wanted to check out was this guy, which I'm pretty sure is the original cap, and it looks pretty darn crusty. And the rubber insulation, the leads was falling away. And I was curious to see, because this site kind of works. We kind of got a raster, and I was able to inject a signal and get an image. But how does this thing actually test out? So let's check the leakage and then the capacitance. So right now, between the red and the black, which is 50 microfarad and 150 volts. So let's first set this to, well, right about 150 on the voltage, and do the leakage check. 50 milliamp scale, essentially no leakage. 5 milliamp scale, barely. So that's 1 milliamp, or well below 1 milliamp. So it seems like it's not a very leaky cap. It may have some life left. Not so fast. Let's try to check the capacitance. And for that, I need to crank up the voltage, because the voltage that's used for checking leakage is also used to power the eye tube. And we need the eye tube to check capacitance, because we balance the bridge and check for an eye open. Now, unfortunately, this eye tube is a bit weak, so I'll keep the camera focused on it. What I'm doing now is rocking the dial to look for an eye open. So this should be 50 microfarad, which is down around here on the scale. So somewhere around here we should get an eye open. But what are we getting? Absolutely nothing. So this capacitor might not have much leakage, but also has no capacitance. Why? It's probably dried out. The electrolyte just isn't doing its thing anymore. By way of comparison, I'll pull out a new capacitor and show you what it should look like. Let's see. Alright, so here's a 22 microfarad cap. So I will switch leads over to it. Alright, and now I will rock the dial on this guy. And there we go. You can see one of these horrible reflections. I killed the overhead lighting, so I think that will help a bit. So there we have maximum eye open at, hey, how about that, right about 22 on the dial. So this thing is working. That's just a bad cap. Now let's check some of the old paper caps. Always a good idea to put this in discharge before you go messing around with these leads, because depending on what mode you're in, they can have some pretty significant voltage on them. Alright, let's check out this guy. 0.02 microfarad, 600 volt. Alright, so leakage. Now this can take considerably more voltage, so, well, let's start out at 400 and see what kind of leakage current we've got. Now there's something. Now for paper or plastic film types, it should really be 0. Electrolytics, a little bit of current is to be expected, but for plastic and paper film, it should really be 0. This thing's supposed to be good up to 600 volts, so let's get this up to 600. And check it again. Not terrible, but again, that should be 0. Let's go and check another one of these guys. About this one, this should be 0.005, 600 volts. And no, I'm not going to bother checking the capacitance. If there's any leakage current, they're bad and they're going to go. I don't care what the capacitance value is. So this should also be good to 600 volts. So let's start out at 400. Not much. Let's go up to 600. Not too bad, nothing really discernible. Let's see what else we got. Now this one has already been replaced with a newer cap at some point in the past. So I'm not too surprised that that one checks out okay. Oh, let's see if we can find one of the old original ones. Let's see. Kind of curious about this guy because this is on the ratio detector and we don't have any sound no matter what I've done. So maybe this guy is bad. 4 microfarad, 150 volts. Let's see. Leads right there. Okay. So 150's right about there. And whoa, we got a ton of leakage current. But it's going down. This is what will happen if a capacitor is capable of being reformed. That will slowly drop and drop and drop. But that's pretty bad. That is pretty bad. Almost 4 milliamps of leakage current. And this process can take quite a while. But considering I've powered up this set quite a few times and it's still this bad, that's not a good sign. So this could very well be why we don't have any sound. Let's go ahead and check the capacitance now on this too. So we should see something when I'm around here on the dial of 4. And nope. I get nothing. Now having excessive leakage current can also affect this too. But basically this is a bad cap. Excessive leakage current and I can't measure the capacitance. That guy's got to go. I finished recapping and replacing out of spec resistors down below and did a little bit of work up in here in the ratio detector circuit. Put the tuner back in, so I figure let's give this another power up. I know I said earlier I was going to recap everything and then resume the video, but I figured I did quite a bit of work down here, so it'd be a good time to take a little pause and see what we got. Hey, we have sound.
We've got my family wrapped up tight. We sleep comfortable at night.
Oh, and we have a video. How about that? So, that's the problem with this approach. Huh, well that looks really pretty bad. Let's see, this is brightness. If you've never seen a really weak picture tube, this is how they look. So it gets brighter and brighter, and I keep turning the brightness up, and it inverts. This bridge did not test very good. Another possibility is the high voltage does still seem to be a little bit low, but that's not a good sign. You have to keep this brightness all, well, no, it's basically unwatchable. But we still got work to do. It may improve, but hey, and it sounds really weak, but there is sound. So here's the downside to shotgunning. I have no idea what the problem was. The tuner may have been resolved simply by me taking it out and putting it back in. I might have knocked some dust loose, maybe fixed a bad connection. Never know. Likewise with the sound. Could have been any one of or multiple of these components that got sound. Never know. On the positive side, it's working better now. So there you go. I didn't learn anything from doing it, other than getting a little more practice soldering and removing old parts. But the end result is it's working better. So pick your poison, you know. If you're new to this and you want to learn, I'd say go through it methodically and replace it one at a time and measure your voltages and see what, and test each part as you, before you replace it and so on. But if you got a bunch of sets in your backlogged and you got some experience, I mean, why not? Why not just blow through it? So I'm going to keep going. So I didn't do all of the sound stuff. There's a little bit more up here to do. Personally, I think a lot of it had to do with replacing that electrolytic that had like no capacitance on it, and some of these leaky caps in the audio. There's quite a few little caps down in here for coupling and filtering and so on, and definitely the ratio detector capacitor. That old one was bad, and that's pretty critical to getting FM sound to work. The recapping is done. Out-of-spec resistors have been replaced. One thing I haven't done is there are still 2 sections of this electrolytic in circuit. They seem to be holding up okay, so I don't think it's really going to be an issue. What I want to do now, one, is see the results of finishing up with the recap, and 2, to try 3 different picture tubes. So this was the one in the box that came with this set, which I haven't tried using yet. So let's see how it performs. Also don't have any shield installed on it. Kind of curious to see how it performs without there being a shield. So remember, this is electrostatically deflected, so any electric fields nearby will definitely have an effect on it. Well, it's pretty bright. And I'm going to guess all these crazy lines here are the result of interference because it's right next to the high voltage box. Let's contrast up all the way. Sound is really good. Needs a bit of tweaking on the width and height, I imagine. It's got a little bit too much width and maybe not enough height. Otherwise, alright. So this is the downside to doing a full recap is, if you're lucky, it'll work pretty well. And the downside is it didn't gain any insight into how the circuit works or anything like that. But anyways, so the set is working pretty well now. So, and this turns out actually is a pretty good picture tube, it looks like. So let's try the others I've got lying around. Also got a green one handy, in case you guys haven't seen me use one of those before. Now this is the one that was in the set when I got it, which I'm pretty darn sure came from a Motorola because of the type of shield it's got. So two things. One, let's see how the brightness and contrast compares. And let's see what effect the shield has, if any. And those are retrace lines. There is a suppression circuit modification I can add to eliminate those. So this seems to be about the same brightness, but the contrast is not as good. In other words, if I wanted to watch this, I've got to turn the brightness down. But what does that mean? It means the modulating grid is not as responsive as with the other picture tube. But there we go, just turn down the brightness about 20%. It's a pretty darn good crisp picture, I gotta say. Generally speaking, 7JP4s aren't so bright. I've never seen a new old stock one, but this is about typical. Basically, you gotta watch them in a dim room. That is a fine, fine picture. There seems to be less interference on this. I'm guessing that's because of the shield. Great. So now let's try a third one, which is one that came from a chassis I gained from some swapping with another collector. Here we go, and this one has the genuine Admiral shield on it. And I haven't touched any of the controls, and we can see this is quite a bit darker. However, let's wait until the program comes back on. Why do I say that? Because this set doesn't have DC restoration. What does that mean? Well, as the video signal, after it gets detected, it's AC coupled, which means we lose the reference level for what's black and what's white. So when you go between different programs, so we were just watching a vintage episode of something, I'm not sure what exactly, but now we're into modern commercial programming. So that's going to have probably different brightness, contrast, and whatnot. So without the DC restoration, typically when you go between different, say, movies, or from nighttime to daytime, or different overall brightness levels, you've got to adjust the set. There's something else curious about this too. Wait till we get to a scene where it's quite white. There is a noticeable burn in the middle. That's so two indications that this picture tube has seen a ton of use. One, it's dim, and two, it's got a burn in the middle. See, these electrostatic sets do not have an ion trap. And generally speaking, they don't really need it because, yes, there are ions in there. It's not a perfect vacuum. Ions meaning there's contaminants in there. There's some atoms of stuff floating around inside that vacuum. When they strike the phosphor, they damage it. Over time, it takes a lot of time. It degrades the phosphor. It gets dimmer. But the ions get deflected along with the electrons, generally speaking, so they get swept back and forth and up and down. So it's like an even darkening or degrading of the phosphor. However, there are some heavier ions. They won't be deflected as much, and they will impinge on the center. Far less of an effect as in a magnetically deflected set, where you most definitely get an ion burn quite quickly without any type of trap. Alright, so now we're back to, well, looks like it was a Twilight Zone episode, and it's still quite dark, so it's definitely a dim picture tube. So let's try cranking up the brightness. And the other characteristic of bad picture tubes, or worn out picture tubes, I can really see that iron burn now, is that when you turn up the brightness, the contrast goes wonky. And it almost kind of inverts at some point. And finally, just for fun, here's a green Phosphor CRT that came out of an oscilloscope. Great for testing. Totally compatible. But obviously green. And the persistence is a little bit different, so the image is a bit fuzzy. Okay, so now what? Well, I want to test these. So now that we've got actual image quality on a number of these 7JP4 picture tubes, we've got one that's pretty good, one that's almost as good, and one that's really, really bad. I want to test them on a Suncor CR70 and see if the readings I get correspond to the image quality we saw. Because that's been some matter of debate about that, and including my own experiences, I've tested quite a few of these, several dozen, and most of them had really good emissions and were quite comparable to each other, but the image quality they produced, the brightness level of the image, definitely varied. So I'm hoping that the test results I get on that one that's really dim are really bad. Otherwise, I really got to question what the value really even is of testing them. And I know the general opinion is the only true test is in a functioning set. I mean, absolutely. I'm not going to disagree with that. But it would be nice to know that at least you can weed out the ones that are almost dead with a tester. And then, of course, I want to try rejuvenating it, which is also a topic of debate. General opinion is that they cannot be rejuvenated, and that's been my experience as well. The electron guns in these, the cathodes are smaller than in your standard magnetically deflected picture tube. So there's really not much material to work with in terms of rejuvenation. However, I do know of one individual who did have some luck with it, and so did I. The picture tube that came in the box along with this set tested really poorly. I do have the footage. I didn't record it very well, so I haven't included it yet. Maybe I will, I don't know, but I'll give you the short version. It tested really, really bad emissions, like almost near zero. I cranked up the filament voltage a bit, let it sit for half an hour. It really didn't budge, so I used the auto restore function, which is not the same as a rejuvenation, which gives it a blast of high voltage, sort of. This is like a more gentle kind of pulsed, elevated G1, G2 filament voltage. And that helped. In fact, it produces a very watchable picture now. But that one may not have been worn out. It might have just been sitting in a box for 60 years, and it kind of needs to get woken up a little bit. That's what I'm thinking. So, very much want to try it on the one that's super weak. Also, that seems to have phosphor that's been damaged, and even if we do rejuvenate the electron gun, there's no way to bring back damaged phosphor. Once it's burned, it's burned. So that will be interesting to see. So that will be coming up next. First up, let's test the one that I think had the best picture, and that's the spare one that came in the box with this Admiral 19A15 I'm currently restoring. I'm pretty sure none of these have shorts because they all seem to work to some extent in the set. Cutoff control isn't doing much of anything, but we've got good emissions. Now you're supposed to, when you're in the cutoff mode, adjust this control so that the needle is on the black mark but I can't. Not on this range, which is minus 68 volts. But if I drop it to minus 52, let's see what happens. And I can. I see this pretty regularly on picture tubes of all types where I have to change the bias range to get the cutoff control to work. What does that mean? It means that the control grid is not as responsive as it should be. It's not as sensitive as it should be, which means the contrast isn't as great as it should be when you're using it in a set. But let's check emissions now. Emissions are quite good. Let's do the life test. Slight decrease. What that does is that reduces the filament voltage. So this test's pretty good. I've never had a brand new 7JP4, so I don't know what one new out of the box would test like. But comparing it to all the used picture tubes I've tested, this tests pretty good. Let's check one of the others now. Next up, the one that was installed with the set when I got it. Cutoff on this, also not doing much of anything on the 68 range. Just to verify that that is correct. 7JP4, yeah, 68 volt range. I have to use this addendum sheet because the 7JP4 is not listed in the chart that came with this. For some reason, over time, they eliminated some of the older cathode ray tube types from the setup chart list. So let's drop it to 52. Now we do get some action, but not as responsive as the one I just tested. I have to go all the way to full maximum rotation on the cutoff control, almost, to get that black area. And emissions. Well, not, kind of erratic, and definitely not as good as the one I just tested. Well, that's good, because this picture tube did not seem to be as good. I remember I had to turn the brightness up when I put this one in the set. So it's good. It's good to see correlation between the two. The emissions is not as good, and the picture wasn't as bright. That's what I was hoping to see. And life test on this. Terrible. That needle shouldn't move, ideally, or move very, very little. So, rejuvenation, as I say, that's general consensus I've seen over the years in the user forums, the vintage TV enthusiast forums, is that these don't rejuvenate. However, I don't know what they used to rejuvenate it, because there's different types. So if we look on this, we've got rejuve, we've got auto restore, we've got manual restore 1, manual restore 2. In other words, there's rejuvenation and there's rejuvenation. So as I mentioned earlier, auto restore is not the same as rejuvenation. Rejuvenation generally, especially in the cheapo, simple testers, they charge up a capacitor, so like 10 microfarad, 500 volt cap. And they discharge it across the cathode and one of the other elements to try to blast contaminants off of the surface and expose some fresh cathode material. That's not what auto restore does on this. Auto restore on this exceeds the specs on the CRT a bit. They elevate the filament voltage, and they, with a controlled pulse, elevate the other element voltages while limiting the current to try to reduce damage. Now the rejuve on this does charge up a cap and blast it, but that's not what auto restore does. So I'm inclined to try auto restore. and see what effect that has. In other words, it's more gentle. You're far less likely to damage it. And the idea is you hold down the red button and you watch this meter, and you let it pulse 3 times. The needle will move while I hold that down as it cycles through the auto restore function and try to clean. It tries to boil off some gunk. Is CRT cathode. It's made from sort of a chemical cocktail, and over time it can get poisoned by contaminants inside the CRT. As I mentioned ions earlier, this is not 100% pure vacuum. There's other stuff in there, and that will degrade the cathode over time. But by heating it and charging up the other elements, you can kind of draw off those contaminations or expose some fresh material. That's the theory anyway, so let's see what happens. So there's 1 pulse, and ideally each time this pulses, the needle should go a little higher. And it actually went a little lower, I think. And then you see what you get. When I've done this before, mostly on magnetically deflected picture tubes, the emissions will improve. The cutoff response will improve. But it sometimes quite rapidly declines to where it was before, or even worse. Let's see what happens in this case. So emissions great, cutoff much better. Let's drop it to the 68 range where it's supposed to be. And hey, now on the 68 range we can get the cutoff, which was not responding before on that range. Put it in the black box, check emissions, hey, they're fantastic. But is that needle going to move? Not yet. Let's try a life test. Rock solid. So you might be thinking, hey, fantastic, I just made this like a brand new picture tube, it's going to work great. Maybe. I suspect it will look a lot better, but how much for how long? Hard to say. So let's see, where are we at? I'm going to let this sit for about 5 minutes. I'm going to put the cutoff right in the middle of that black box. Do emissions. We're just a tick over 13. I will come back in 5 minutes and let's see where things are at. It's been closer to 10 minutes now, and the needle has dropped a little. Now it's a hair below 13, whereas before it was above 13. And the cutoff is now no longer in the center of the black area. It's actually off to the left. In other words, it has decreased. So, and I think it will continue to decrease over time. But it'll be interesting to see what it looks like back in the set. Now finally let's test the one that is really, seems to be really worn out, the one that has the ion burn in a terrible image. Now even if you could rebuild these 7JP4s, once that phosphor gets damaged, that's it. So my advice to you, if you've got some of these 7-inch sets, don't use them very often. Demonstrate them for people, but don't leave them running for hours, because once these are gone, they're gone. Shorts. No, I'm not expecting much of anything out of this one. Oh, look at that. It's got fantastic emissions. That's what I was afraid of. That's why testing these, unfortunately, is of dubious value. Because I could list this on eBay right now and say, hey, use 7JP4, fantastic emissions, include a picture of this, include this, a video of me showing me testing it with great emissions. Then you put it in a set and it's crap. The worst 7JP4 I've ever seen but it shows great emissions. That's disappointing. Again, no cutoff response on the 68 range, 52 range, yeah, it's got cutoff response. Put it inside the black area. Great emissions. Maybe even better than the other. It's even higher than the one that we just tested. Life test. Pretty respectable. Barely moves. So it seems to test great, but we know it produces a terrible image. Because the phosphor's worn out, I suspect. Now why? Why is it so bad? Maybe there were some extra contaminants. Maybe the getter's worn out. Haven't really looked at it because it's got the shield on there. It's still got to have a pretty good vacuum or it won't produce any image. Well, just for the heck of it, since we know it's already terrible, I might as well try the auto restore, because if nothing else it may improve the contrast a bit. And this needle's going up quite a bit higher than the one that we just did. So of the three, I think this actually has the best emissions, but the worst picture. But no cutoff on the 68 range still, so it actually did not improve anything in that regard. It actually tests on emissions a little bit worse now than it did a moment ago. And it seems to have less cutoff response on the 68 range now. In fact, it's pretty much gone. So I may have actually made this CRT a little bit worse. Alright, well, let's pop these last two back in the set now and see what difference it makes, if any. I don't expect this one's going to be a whole lot different, but the one just prior to it, the one that came installed in the set, may be a little bit better now. So here's the one that tested so poorly, and yeah, guess what? It's still absolutely horrible. Huge ion burn in the center and inverted video. So that accomplished absolutely nothing. And now the one that seemed to kind of rejuvenate. You know, it does seem a bit brighter. When I filmed the earlier installment, I did it late at night. And now it's in the morning, so we've got some more ambient lighting in here, and that's actually quite watchable. Just turn the brightness down a little bit. Yeah, I would say that that definitely made an improvement. You could actually watch this set in a somewhat illuminated room, whereas before you pretty much had to have the lights out to watch it. So what can we conclude from all this? At least with this tester, with my tester, which I have calibrated and seems to be working correctly, readings for 7JP4 should be taken with a huge grain of salt. Because you can have very good emissions and an absolutely horrible picture. You've got to see it running in a set. Can rejuvenation work? Maybe. Again, I didn't do the traditional classic rejuvenation. I did the auto restore, which is less aggressive. And at least with this one, it did seem to improve things. How much? Well, noticeably. How long will it last? I cannot say. Alrighty, now what? Well, the set's working pretty well. I am going to now clean it up while I got the picture tube out. Use a little simple green and a toothbrush and clean off the surface grime. And then select a picture tube, and I'm going to go with the one that was installed in it, the one that I did the auto restore on. I'm working on taking the shield off right now, which was kind of a hodgepodge. I was a bit mistaken. This wasn't one taken directly from a Motorola. This part may have been, but this is homemade. This is just some sheet copper, I think, that's painted black that somebody had coiled around this, which might also be homemade. I'm not entirely sure. It looks very similar. Oh, it's the same type of material as that. This might actually be mu metal, which is what you'd find in a professional oscilloscope. Or, I mean, there were a number of 7-inch sets, and I have not gotten around to working on all of them. This could have been from one I haven't seen yet, like a Sentinel TV400 or some such, but I have not seen a shield quite like this. And underneath that is some cardboard and some friction tape. I'm going to get all that off and then transfer the shield from the very, very, very worn out one, so I can get all the proper original Admiral stuff going on. And then give it another once over down below, make sure everything looks up to snuff, and then see about putting the set back together. Oh yeah, and the speaker. Oh, what to do about the speaker. I haven't even bothered to take it off of the board because, well, not much to work with there. Yes, I have resurrected some speaker cones. I think this one's a bit too far gone. So I will look through the sets that I have. Mostly I got spare chassis and some extra worn out picture tubes. I don't think I have any spare speakers that are in good shape. But I do have some that are unrestored that, at least temporarily now, I think I'll swap out one of the speakers. And as somebody commented, this grill cloth is in fine shape, and I forgot that the other example I have of this set does not have the original grill cloth in it. It's a little bit of dirt on there I will try to very carefully clean off. Put a discoloration down here. It might clean up, or it might just be kind of too faded and gone, I don't know, but otherwise, as far as these go, that's about as good as it gets. The original grill cloth. Not quite perfect, some of the wavy lines there, but it is glued down to this board, so that may just be how it was made. Also, I'm not sure how much of this is exposed in the front of the set. Well, I'm guessing the area we can see that looks a bit faded, so probably all that, so I'm sure this is a bit visible. Which does beg the question, what happened to this? I mean, usually speakers get trashed because kids poke their fingers in from the front, or critters do or something. This has been eaten out from the back. Now, there was some minor evidence that there may have been some critters in this set, but not extensively. There wasn't the usual corrosion from urine on the chassis. There was no bedding material packed in there. There was no wire insulation shoot off or anything like that. So for some critter to have come all the way into the set, not really disturb anything, went right to trashing the speaker cone seems a little implausible. Or when somebody was working on this set, they may have just accidentally shoved their fingers through from the back. And this cone does feel super crazy fragile, like it's kind of disintegrating as I just touch it. Recone it, yeah, well, sure, the voice coil's there, yeah, theoretically. I got a feeling finding a off-the-shelf replacement cone of this size is not really going to be very likely from what I've seen in forums and stuff. That and these were common back in the day. It's like a 3.5-inch, 4-inch round speaker. They used them in a lot of radios and TVs, but replacement cones are not so easy to find, so I'll say that for another day. Speaker reconing is not really my forte. Alright, so I will continue to carefully get the shield off, and then I'll give this a real good cleaning. It's quite filthy. And it's surprisingly defect-free. Usually these 7JP4s have air bubbles in the front. Check out that one out, Admiral. Yeah, so sure, yeah, this one's got one right here. In a very visible area. It's also got some scratches in the glass, which are kind of dangerous. This thing is under vacuum, and there's a ton of atmospheric pressure on that glass, and getting scratches in it is not a safe thing to have, because it can compromise the integrity of the glass envelope and kapow, implosion. I don't know what I'm going to do with this. I mean, there's really no hope of ever getting it to produce a good picture again, and I'm not crazy about having the scratches on it. Hate to trash it though. On the other hand, it does have a good base and all the pins are tight. These 14-pin bases can be a little hard to find, and I have some that are a bit damaged on other examples. Often those pins come loose. This base is a little loose on this guy. The pins are pretty tight though. That's, well, very often these pins, because there's just so many pins on this thing from the base, when you take it on and off, you start getting wiggly and sometimes break loose. And this also has air bubbles, one very noticeable one right here, and several smaller ones throughout. Alright, so this one was actually a fairly easy restore, other than replacing the high voltage coil, which was a surprise, and playing around with some picture tubes, but otherwise a very straightforward recap. Here's one final thing worth noting. These picture tubes, well, generally all tubes have a getter inside of them. Getter is a reactive metal deposited on the inside of the glass to try to scrub up, attract any air molecules, gas molecules left floating around inside. So there's a little cup inside, and it has material in it. After they evacuate the tube, they pass an RF coil on the outside of the tube, and they zap it, and it causes it to heat up and kind of, well, get attracted to the side of the glass. That's what that rainbowish, metallic, dark kind of splotch is there. You want to see that. That means that it's present and doing what it's supposed to do. Let's take a look at this picture tube that functions so badly. It's gone. It's all been used up. What does that mean? That contamination's gotten inside, likely some air leak, and it's reacted with it, and it did all that it could, but there's still some stuff left inside, and that's what must be bombarding the phosphor. And I suspect that is why, even though it has good emissions seemingly on the tester, the picture is so dim. This phosphor has been poisoned, basically, by contamination. Oh, and one final thing. I believe another reason why these generally never got rebuilt was because these are different kind of glass. It's my understanding it's more akin to like Pyrex versus I think they use soda glass on conventional picture tubes. And one notable construction difference, I think because of the type of glass, is that this is made up of pieces that are, well, like molded together. So there's the front and then the two halves. And see that line running down the side? There's one on the other side, and then there's one all around the front. You don't see that on magnetically deflected picture tubes. They also seem to have thicker glass. Of course, those are larger generally, so generally the larger the picture tube, you got more force on it, so you got to use thicker glass. But I do believe that this type of glass is far more difficult to work with in terms of opening up the neck and then attaching a new piece of glass and attaching it and then re-evacuating it. Bark. 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 Sure.